Hello, good morning viewers. Here is another critical question involving logarithm. We're asked to show that half of the logarithm of p plus logarithm of q is exactly equal to the logarithm of p plus q all divided by root 13, provided that p squared plus q squared is equal to 11pq. I believe there is different ways of giving this question a try. For instance, some people may decide to simplify this, relate it with some of the terms in this first equation to show that it is exactly equal to the right-hand side. And some people may decide to simplify the right-hand side, relate some of the terms with the first equation to show that it is exactly equal to the left-hand side. But for me, I will simplify the first equation and show that the left and the right-hand side of this equation are equal. One thing you should notice here is that in all of this equation, we do not have anything that has to do with p squared plus q squared. But I know if we should square p plus q, we're going to obtain a term that corresponds to p squared plus q squared. And let us do that. So p plus q all squared, this will be equal to p squared plus q squared plus 2 multiplied by p multiplied by q. This is exactly the expansion of p plus q squared. So you can see that we have exactly this in our first equation as 11pq. So we can substitute that by 11pq. And therefore p plus q all squared will be equal to 11pq plus 2 pq. All of these two terms are like terms, so we can join them together. 11pq plus 2pq is equal to 13pq. Therefore, p plus q all squared is equal to 13pq. Now, to get rid of this power of 2, we can take the square root of both sides. If you take the square root of the left-hand side, you will be left with p plus q. If you take the square root of the right-hand side, we have plus or minus the square root of 13pq. And remember that we are going to introduce a logarithm. Therefore, we only need the positive value. So p plus q will be equal to square root of 13 multiplied by square root of pq. So from here, we can make square root of pq the subject. So square root of pq is nothing but p plus q divided by root 13. And from one of the laws of indices, square root can be written as power of 1 over 2. So we have pq all raised to the power of 1 over 2. It is the same thing as the square root. This is equal to p plus q divided by root 13. All right, now what we need to do is to introduce logarithm to both sides. So we have log of the left-hand side, which is pq raised to the power of 1 over 2. This is equal to log of p plus q divided by root 13. And from one of the laws of logarithm, this power of 1 over 2 can drop down to multiply. So we have 1 divided by 2 log of pq. And this is equal to log of p plus q divided by root 13. From another law of logarithm, it says that if we have log of ab, this is the same thing as log of a plus log of b. So we can introduce this to the left-hand side of our equation. Therefore, finally, we have 1 over 2 multiplied by log of p plus log of q. And to the right-hand side, we have log of p plus q divided by square root of 13. Now, what we have here is exactly what we are asked to prove. Look at it here. Can you see that? They are exactly the same and hence proved. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.